All right, guys, so what we're looking at here is a problem from 2021. This is a particle motion example. This problem is fairly straightforward. There's not an awful lot of weird stuff going on here. So let's go ahead and jump right in and see what they give us. So it says a particle P is moving along the x-axis, and you'll notice that it gives us in this problem a velocity function for particle P, as well as an initial position and a time interval from 0 to pi. Then it gives us a second particle that is moving that they also give us the velocity function, and they give us a different starting position at time equals 0. So really the hardest part about this problem is keeping everything that is true about each of the particles with that particular particle, because other than that, again, it's fairly straightforward. So the first thing it wants is find the positions of particles P and Q at time equals 1. Well, in order to find position, we take the initial position of each of the particles individually. So I take my position of particle P, initial position, and then I do the integral from 0 to when it wants the position of that particular function, just like that right there. And then when I type that into my calculator, I get 5.371. Then I do the exact same thing with Q. So I go 10 plus the integral from 0 to 1, but we have to make sure that we use our Q velocity instead of our P velocity. And when we do that, we get 8.564. So there are our positions for both particle P and Q. The second one says, so that was letter A. Letter B says, are they moving towards each other or away from each other? Well, in order to answer this question, there's two things we need to know. First of all, we need to know where each of the particles are, and we found that in letter A. So here's particle P and here's particle Q. Particle P is right here at 5.371, and particle Q is at 8.564. Now we want to know, are they moving towards each other or away from each other? The way that we find that is we just find the velocity of each of the particles at the time that we are interested in. We already have a velocity function, so when I plug 1 into my P particle, I get 0.841, which means it's moving in this direction. If I plug 1 into my Q velocity function, I get -1, which means it's moving in this direction. So we can say that those two are moving towards each other. And honestly, just due to the fact that we know the position and we know the velocities are not the same, the reasoning, honestly, is as long as you have both the velocities and both of the positions labeled, that's enough to say that they're moving towards each other. For letter C, we want to find the acceleration of particle P at time equals 1. So to find the acceleration, I just take the velocity, except it's particle Q, and I plug in 1. When I do that, I get 1.027. Then it wants to know, is the speed increasing or decreasing at that time? Well, in order to tell whether speed is increasing or decreasing, what we do is we compare the velocity and the acceleration. If they match up, it's moving in the same direction. If it's not, then they're moving in opposite directions. And as we can see here, it's moving in opposite directions, or the forces are acting not together. So we can say that the speed is decreasing because the acceleration is positive, the velocity is negative. Letter D wants to know the total distance traveled by particle P. So again, I think one of the hardest parts of this problem is understanding that I have to keep the particles straight. Luckily for us, the formula for total distance traveled is pretty easy. It's just the absolute value of the velocity function. And when I do that, I type that right into my calculator, and as long as my calculator's in the correct mode, I get 1.931 as my correct answer there. Hopefully that problem made sense. I didn't think there was an awful lot in this problem that was, maybe letter B was a little bit tricky, but everything else was fairly straightforward. If you have any questions about this one or any others, please let me know.